All right, welcome. Um, how's it going?
Hi, he's good.
All right, so obviously got a lot of stuff to talk about today. Just give you a heads up. I am finished grading. Let's see here. PA2, Sprint 2, PA3. I'm gonna post tonight, Sprint 3, and then I'm thinking Thursday I should get Sprint 4 posted. So so Thursday I should be completely caught up with the grading. And remember the sprints are there to kind of give you a kick in the pants to keep you moving, right? And where you can start seeing your design patterns applied. And where they're going to really pay off now is milestone one, right? Milestone one is basically the whole kind of first pass of the kind of the game starting to come together using quite a bit of patterns actually. So overall, the people who did the assignments did really well. And there were some people who just didn't do the assignments. I'm not sure what the story is there. One word of advice, make sure you verify your builds, make sure the builds are working. I can't grade if I can't build and walk through the code. So just make sure you verify your builds. So, all right, questions on milestone one.
I had kind of a question on milestone one. This was something that was kind of an issue as I was recording my sprint 4 and was a little confused about it for this. It seems like there's a lot of different demos we have to do. Should we almost be like making an edited video of all the different demos, or just do them all live on the spot?
Yeah, live on the spot. I don't care if there's blunders. I don't care if it's as smooth, right?
Okay.
Don't and what I'm talking about for the milestone is really a short little burst, right? You're going to so thought I figured this. Thought one of you guys showed me how to do this. How do you make this full screen?
Alt L.
Thank you.
Either that, it's Control L.
There you go.
Control L then. Yep.
Yeah, you guys are you know the trickery. All right. So here's all these patterns, right? And let's just talk about the singleton, right? Let's take the first one, right? So you did it, yes. Make sure you have verified. If you click this, I'm trusting that it's working and compiling, right? You click this and then you say, and then it doesn't compile and I don't grade it. You can't cry because you click the button. So click this only after you verified it, and then you're happy with that, stuff there. A few students have forgotten files, and I'm sure the files are on their machine, but they didn't submit it to the version control, right? So make sure you do that. All right, so let's go through this part right here. So really, I'm going to see a lot of things running on the screen, right? So, you show off the whole, little demo where the guy is, the aliens are marching back and forth in a grid, and they're going back and forth, and you toggle bounding boxes and stuff like that. And then, oh man, this mouse is not going down. There we go. All right. Good. All right, so here, our demos right into object pulling. Oh, yeah. Oh, here we go. So just, show the, open up, the UMLs that are inside the Visual Studio are totally fine. Those are appropriate. Even though they don't do the little open diamond or solid diamond pattern, the rest of it is there. Don't show everything. Show the stuff that counts. Don't show every single field. Don't show every single method. Do some selective editing where you close off some of those classes, so you just show the part that's worth talking about, right? But just show the UML, show where it is, show, like, okay, here's how the mechanics work, And here is it being called. You can see, and you can even like, after you show the demo for 30 seconds, you show it go back and forth twice or something like that. Then you go in there and show each of these patterns. And I'm really looking at a 30-second show and tell on this, right? So so let me try to do that, just to give you guys an example of it.
So it's really like the 2-minute sprints, but even shorter because you've already seen it.
Right, because the sprints to me is the deeper dive, right? And the sprints and the PAs are really kind of proof. This is like on, see, I got it, check, shut up, Ed, here it is, right? And you keep going. And what I notice is when people haven't done this, they don't show me it. And they haven't gotten the priority queue working, they don't show it off. If they haven't gotten the composite pattern with the leaves and composites, then they don't show it off, right? And the whole idea is that, remember, we can make this whole game in a glorified for loop. So I'm not as impressed that the game's working. I'm more impressed that you're using the right mechanics underneath the hood, right? So let's go ahead. You have to show enough to prove to me that you have the pattern, right? So, all right, so what was the pattern we're doing? We're doing right here, Sprite Box Manager, right? Sprite Box Manager, right? So show there's a singleton, right? So, all right, so here's the Sprite Box Manager. You can see down here, here's my static instance of the static instance of this class. There's only one of these, no matter where it's allocated or accessed in the game, it's accessed right here. This is the one and only instance. So how we do this is when the thing is actually created, it's going to check the instance initially is null. It's going to be created. So this is when the constructor is actually called. So the constructor is being called there. It's going to return, it's going to initialize the instance. From this point on, the instance is created. So here's the instance. Sprite Box Manager, boom, there's where it's actually created. So this is the one place it's created in the whole game. So now wherever I look for Sprite Box Manager, right? Sprite Box Manager, here, find. So Sprite Box Manager, at this point right here, this is just a global call to it. So then when I go into this, find, you can see, first thing I do is to get instance, which then grabs that instance. So this is the one instance that was just initialized, comes back. And now from that point here, I can use this directly. So I can now act as if a first citizen by using that instance and getting into functions and methods, right? That's it, nothing more, right? If you want to, you can show other locations for the Sprite Box Manager, but that was one. And I just use to find references, right? So here's this is the create, here's the find, and then I don't have I'm not actually loading up Sprite boxes. So Sprite Manager, right? So here you can see, boom, and so here's like all the ads, right? So here's the ad. So you would have Sprite Box Manager in here as well, and then you would show that off. So like boom, you can show that here it is, here's a good instance. Now at this point I have an instance handle. From there I can grab methods and access stuff directly. Nothing more, just quick and dirty, in and out, next guy. Just show me enough to convince me that you have a singleton, right? So the idea is that you would have this alien grid moving back and forth on the screen. And you, did I specify boxes on this or no?
No.
Okay, I'm going to amend this. Obviously, should have boxes, right? We should have boxes. Otherwise, why would we have a box manager?
Yeah.
Right. So, all right. So I'm going to do a friendly amendment here. And so your aliens are going to go like this, because like you're supposed to also show off the composite pattern, right?
Mhm.
Yeah, so you have the grid. Yeah, composite pattern and assembly of grids and columns, which you can even show with the boxes as well. So you would have here the, here's the alien, right? And then you would have
I actually ran into a little bit of an issue like trying to do that over the weekend. Like, so that you have the null objects for the column and the grid.
right.
And like maybe I was just like maybe it's just because like I was using the reference code and I haven't tried a couple of things yet. But, like what I ran into is the like because they're the null objects, they're not actually doing anything. And so like obviously you don't get any updates or rendering or displaying on the boxes when you enable the boxes.
Right. So
like
you should be able to, in today's demo should have the columns in there. So you should be able to see it from today's demos, but
okay,
I'll even take just that every alien has a box on it. That'd
okay.
be good enough. But in reality, you would probably have then columns, right? And then you would have a super box for the grid, right?
And like what that would actually look like is it all going to be stacked up on top of each other.
Right. So all you're gonna really see is the horizontal lines, because the
Yeah.
lines will be literally on top of each other. You're absolutely right.
Okay. Yeah, I'm sure I'm probably just like, it's just because like I'm not doing anything and I was thinking about it wrong. I had like a mess of code and then I just reverted it.
Right.
So all the
I was like-
boxes are null objects then?
No, boxes are not null objects.
Oh,
So
No, she was talking about the grid.
for the grid, all right, for
Oh.
the grid. Yeah, so there's
Yeah.
the null, it's a game object, and it's just what you populate with. You populate, do you want to sit there and show the sprite? No, there's no sprite. So it'd be a null sprite, but there'd be a real sprite box.
oh, so let's say like if there's a collision and we shot an alien, so we would replace that image with the null object that wouldn't take a collision point or whatever. Is that correct?
Well, you would just have to put it in a sprite batch,
Yeah.
like, and then you just draw like that's it. You just draw over it.
So you can see right here, each one has a box, but then this outside column has a box. Let me see if I can get that outside column looking right.
Yeah, I was gonna mention you have to have the positions like correct. So that would like the important thing, because I don't think necessarily they have the positions in there like exactly, because I had to mess with that a bit.
I think so like your game object null has a collision object, which has the actual sprite box and the box for the collisions. So you still have to have your game object null make updates to its collision box and everything like that. You're just not making updates to the sprite or anything because there is no sprite attached to it.
Yep, you got it.
I don't know. I guess I'm still confused about when I should use a null object. Like, can I
Okay.
just put like a random that Space Invaders image on there and call that a null object?
No, you shouldn't do that. So here, so let's go, so just take a game object, right? And let's just start off with a diagram. Diagram. I have no clue what project I'm in right now, so this is really good. All right, class diagram, right? All right, so we take a game object. So we'll take it all the way from a column, right? The column is something we're talking about, right? We just want to draw the column. So here's the game object column, right? It's part of a composite, which is part of a game object, right? Right. All right. So now the game object itself, right? And what it comes down to is kind of a fun, it takes a while to kind of get adjusted to it, but really all we're doing here is boxes, right? Our code now becomes to which connections to which boxes, and the details on boxes are relatively simple, right? So a game object, right? Oops. Has a pointer to this proxy, right? Now, obviously, this can be a real proxy, or it can be a real sprite or proxy. I like proxies because that gives me the most flexibility, right? So this way, if they're all pointing to an alien, if I swap this alien over here, then everybody can animate at the same time, right? So that's nice. So I like the proxy part here. So this is how it gets rendered, right? So this has a render. So now this is where we kind of get into this whole thing. So how do we populate this, right? So now we have a collision object, right? So here's a collision object, and the collision object has a collision box sprite, and probably you can even make this a box sprite proxy if you wanted to, and then the actual collision rectangle, okay? So this is kind of the column, right? So now how do we populate this determines what we see on the screen. So if we don't want to draw the column, you know, we don't have a alien, we don't have something physically to draw for the column, we don't do proxy here, remove it. And instead, we will look at the sprite proxy null, right? And what this is going to do so now it's still connected to a sprite proxy, but it's really a null. You know, I specialize in it's called a null proxy, right? And what does this thing do? Well, why is this interesting? Because this guy, I'm going to put the collision on the other side for right now, this way I can expand this out easier. A lot of times I hate going the other direction. Oops. All right, so here's the on the proxy side here, the game object points to a proxy. This proxy has a function called render, right? Cool, so let's just do that. So there's render. And update, those are like the two guys that are most important, right? So all proxies have that. And if we look at this function, it can be, you know, it's a virtual function, it's overridden. And oops, we don't want to go to the proxy, we want to go to there. All right. Yeah, proxy. Damn arrows. All right, here we go. Take 17. All right, there you go. So this is our proxy, right? And if we look in the base class of this, the base class has these two contracts, right? So now, stupid line. All right. Now let me shuffle shit down a little more. All right, so now we're seeing this pattern here that a game object points to a proxy. The proxy has some things. It points to a real sprite. But I'm going to specialize and derive from this. So ignore this guy for a second. And now I'm just going to be worried about the render and update. So then null here has a render and update. And then its render do nothing. Right? And this is important, this do nothing, right? So what this means is when you draw the column will basically go to the proxy. The proxy will go here and then will go into the render, and the render will do nothing. So it will always call render on a column, you know, so you would draw the column, but the function that draws the column does nothing.
When would we want a column with no aliens? Like in our milestone?
Right. That's your column. Your column is no aliens. Underneath
Well, I
the
thought,
column is your aliens, right? The column is the composite.
I thought the aliens were inside that column composite.
No, they're attached as leaves, right? So
Oh.
we have this, we have the grid, right? This is a composite. And then it points to a column. That's a composite. And then underneath this are aliens.
Oh, I see what you're saying now when it's going through and passing through. So I guess I've always had that implemented then already because the columns draw nothing. Oh my God. Thank
Okay.
you.
Yeah, so this is actually, this will draw the sprite. It'll be a null sprite because it doesn't draw anything, right?
Mhm.
But the collision object, right? The collision object, let me do a different color. The collision object, right, has hooked to it a box sprite. So nothing gets rendered here, but the collision will draw a box sprite.
Okay.
And this will, the sprite will, will be a null. So nothing gets drawn there. And then the collision will have a box sprite, right? So these two have boxes. And now let's look at an alien, right? So an
Because sometimes
alien,
I get confused with the term column because sometimes I think about the boxes that are surrounding the aliens, but then I forget
That
that
is
it's
it.
also a composite.
no,
you
that
know?
that is that it's a node, right? It's a node. So the box is there.
No, but like I was also thinking about the boxes that go around the aliens. It's technically kind of like a column of aliens inside a box. I don't know.
That's the same thing. We're actually in software terms, you can use this, I coined this term, but I think it's absolutely appropriate. We're arguably agreeing, right? So we're saying the same thing, just slightly different wording. So here's your alien, right? And what does an alien have? Well, the alien does have a proxy sprite, which then points to the real sprite. And now you get the alien up here, here's the little guy, right? And then the collision object here points to a box sprite, right? So this whole scene here, we have this, let's draw this backwards. Let's say, okay, here's our alien. So our alien's right here, right? The box that goes around it, we'll call box one, right here. Okay. Now the column might have multiple, there might be multiple aliens. Right. So let's just simulate that with. Right. And so each one of these has their respective boxes. Right. So there's that. Now I'm gonna shrink this off because it's too big. Right. So 0, 1, 2, 0, 1, 2, right? They each have a box around it. Put the box in pink. Right. Now the column, right? The column has no box. I mean, no sprite itself. There's nothing to draw for the sprite, but we can draw the box. So now we can draw this box. There's that box. And then we would have multiple columns, right? Right. And then the grid has no sprite, but it has a box. So now here's the grid. So we're going to use the null sprites here to say there's no sprite. But then on the collision pathway, it has a collision box.
Thank you. Okay, I see the difference now.
Right? So what I just drew here is this pattern. Right? And so these are this right here is your composite. So let's make it square. And then the orange ones are leaf. So these are their aliens. And there's 3 aliens there. This is your column 0, column 1, and this is your grid, right? And it's almost kind of like a checkbox, like going, okay, sprite, game sprite, no. Box sprite, yes. Then for your collision, game sprite, no. And box sprite, yes. And then on your aliens, game sprite, yes. Box sprite, yes. And so whenever you see the no, you put a null object there.
Thank you. This illustration is so good.
So this is why the null object is so awesome, is that you draw it. Just to draw does nothing. So your code always goes boom, 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 call, draw, 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 draw. And sometimes it goes all the way into, boom, boom, into the function call and it goes, nothing. What's nice about the null sprite is that you don't have to put a special case. You don't have to say, if this is disabled, skip it. Because every time you put a conditional, first of all, it slows down the program because that's a branch prediction, which actually throttles your cache. But the second reason is every time you have bugs in your code, it's almost always around a boundary or an edge condition. You're removing those things. Right? So we have a full game sprite, a game object, that has a sprite and a box, right? We have a collision, which is a graphical representation, but when we run the game, we actually turn off the boxes, so you don't ever see a collision, a column or a grid. You never see that manifest on the screen. You use it for debugging, right? So that's there, but the game sprite is off, right? And we have another scenario which is, your score, right? So let's say your score is, 100. Well, what is that? That's an object that has a game sprite, right? But the collision object is a null collision object, because you don't need a collision for the score. The score is just there, right? Each picture of the letter is a box. So that's an example of the reverse, where we would have a sprite on the screen, but we wouldn't have a collision box to go with it. Or you know how like you look at the game and there's here's your player guy, right? And then you would have your spare lives right here. You can't collide these guys. They're just there graphically to show you something, right? So how do you draw these spare lives, right? So here's the missile going up, your ship is going back and forth. How do you draw these? Well, this is a game object. Might as well draw it up here. Right? And then the collision object is a null collision object. A null collision object has a null box sprite, right? And then it has a null rectangle. Well, the rectangle would just be not populated, right? And then on up here would be sprite, and that would be the picture of this guy. So you would have all this area here would be null. So if you try to draw a box, there's no box that goes around here. But you want it displayed on the screen, so you just have the sprite. So it depends on whatever you don't want something, you put a null object in its place. And that's kind of the trick, so you don't have special conditions.
Thank you.
So for the demo, and I will send this formally out here, I will be very happy if you just show me, here's your aliens. And then you have, I'm just going to draw 5 of these, even though there's 11 columns. Right. If you just put the collision box around each one, right? And remember, all the collision boxes should be on their own sprite batch. So they should be, they're on their own sprite batch. There's collision box. Boxes are on a you can put it on a different sprite batch. So then you can toggle it on and off and say, boom, they're on, oop, they're all off. Because you can disable a collision sprite batch.
I'm a little confused. I thought it had said in the milestone that collision and visitor pattern aren't required for this milestone.
No, this is boxes. We need boxes.
Oh, okay.
Yeah, I need to see the boxes up there. That's all.
Yeah, we're not talking about collisions.
Yeah, there's no collisions in this. No collisions.
That's just for like, they're just showing you like, well, that's what we're actually gonna do. They're just giving an example.
Yeah, I just want to see some boxes on the screen.
So this is required for the milestone now.
Yeah, well, the problem here is how do you demonstrate it if you're not using it?
Demonstrate what, the no objects?
No, how do you demonstrate a box manager when you're not using the box manager? Give me some sprite boxes.
Just use with the other sprites, the other managers, but sure, yeah.
No, I want to make sure this is in there. So this way, the whole key is more of this that we show, then when we're going into the final thing that's going to have even more stuff, these are like covered already. I don't want you to do a 2-hour demonstration for me at the end of the quarter. We can get these done now, and then when we move forward, then they should run better, right?
Yeah, so okay, so I actually did not have the boxes added.
Add the boxes. Yeah.
Yeah, okay, so that's a requirement now.
Yeah, it's due. Yeah, just throw on boxes up there. I want to see some boxes. So I'm sorry, I put the requirement in here and everything else. I didn't enumerate it down here in the demo part.
And this due through Sunday.
Yeah.
Okay.
There's nothing hard here. You add some boxes. It'll take you 2 seconds, right? All right. And so somebody had a question about long-term and short-term new. Anybody want to elaborate more on that, or was that settled out?
I did have one question on that,
Mhm.
but I think I know the answer. So items produced by the factory, like even though those are, we do the new, we keep them around for everything, even when we're like actually using them later on, those are still considered long-term news because the game object itself doesn't go away. It would just have its collision object swapped to null when the when the object's like defeated or whatever
Right.
and stuff like
So-
that. So they are permanent. We're never going
Right.
to call delete
So-
on those.
So like right here, let's look at the the node the sprite manager, right? The sprite
So
manager.
this is the factory, not the game object factory. The
The
sprite
same-
managers are of course the long-term news because those
Right.
are,
Okay, yeah, I'm gonna
stay
say
forever.
anything that's inside a manager is long-term news by definition.
but like the
The
game
factory,
object, the game object is done by the factory.
done
alien
by the
factory.
factory, but then it's owned by the manager.
Okay, so it's
It's
owned
a
by
long-term- it's a
a
long-term
game
node.
node, which is owned by the
Game
game
node
node
manager.
manager.
Right.
Okay,
So that's still long-term. Because you don't give it up.
okay,
So the things that are short-term, like if for some reason, right, you needed to pass in a rectangle here, right? Let's say like in this code here, you needed a rectangle. So you go, rectangle, and you go, PR rec new, and then here's, right? And then in some function down here, you go, oh, no. Here's the rectangle. P rectangle, right? Now you only created here, you filled it up and you sent it off. Then when this thing goes over, it gets a copy of it. If you don't take ownership of this, so we go into this function and there's no ownership, we're not transferring the ownership. Well, then that would be a short-term new. This is going to be marked for deletion pretty quickly here.
Okay.
So what I'm really looking for is I try and identify what is associated to a manager at some point, however you create it, whether you create it in a factory and then you transfer it over. If you as long as it lands on a manager, that's long-term new. The manager takes care of it, takes ownership, it deals with it, right? Anything that you create for just a short term and then when it leaves scope, you don't use anymore. That's a short-term new. So here, let's look at this. This bird column, right, is we're creating it here, but then the column is being here, whereas there's an attached, it's added to the grid. Okay, then later this grid is
it ends up on the game node manager.
yeah, it ends up in game node manager. I think it's passed into the factory itself, right? Yeah, attached right here.
Mhm.
So therefore it's a part of the manager. So these are all long-term news. So I would just put in here, LTN, added to game object. Right, that's it.
Piggyback off of that, we don't have to like show in the demo every single new line,
No,
right? We can just-
no.
Okay, good,
No.
thanks.
So then like here, this factory, this is a short-term new, right? And this is like, you can sit there and say, factory.
Well, but in the
Really?
alien factory though, the game objects aren't, like, you can't reuse the game object. Like you could reuse the octopus game object, but only if you needed another octopus.
No, but who owns it? Who's taking ownership of this? Nobody's taking ownership of this factory. As soon as we're using this, it's like a plastic coating on your package. You throw it away, right? At this
Yeah,
point,
but
right here,
like-
it's thrown away.
I mean, if I called game object node manager remove on one of the game objects,
Right. So-
the game
the-
object that's internal, that would have to get deleted because we don't know what we're gonna reuse the game object node for.
yet.
Okay.
Yet. We're gonna have a ghost manager where basically when you're pulling something off of the game object. So if you think about it, we're making a game, right?
Mhm.
So at some point here, you're gonna delete this guy, right?
Yeah.
Right. So you delete him. boop, he's gone. Well, you're going to add it to a ghost manager. Right? And so now this ghost manager will own it. And then when you want to reset this level, you go back to the ghost manager and you pluck it off there and you reuse it.
Okay.
You know what I mean? So this is,
Yeah.
and the ghost manager can handle anything. You know, it's just literally, we just throw everything out and
Yeah, and then you say, okay, I need another squid, and
Right.
I want to see if you have one first before I make a new one.
right, exactly.
So instead of like using the factory directly, either inside the factory, you check with the ghost manager first before you create it, or you do something like that.
Right, yeah.
Got it.
So then technically this is behaving like, at this point, then our memory pools, our pooling manager becomes,
Mhm.
and I'm ahead of myself a little bit, but it becomes a flyweight pattern.
Okay.
And a flyweight pattern basically says, I don't have it, create it, attach it to the manager. Now in subsequent requests, I can just use the one that I already have associated, right?
If it's available.
Right, if it's available, and if not, create it new. And then if it's depleted, add more new, but it's a sticky list. So the manager starts behaving more like a flyweight.
Got it.
But we're not here, so don't worry about that. So like,
That's okay. That clear. I figured it was just a long-term new for now, but
yeah, it's a
I wanted to
long-term- it's a long-term
clarify.
new, and we're gonna slowly control the ownership of that.
Mhm.
But the
Because
real
like right
issue-
now they would just go away.
right.
that'd
So
be
like
the
right
only
here, if I call
difference.
new on the iterator, right?
That's a short-term new because you use it
Short-term new,
once and then you
right.
toss it out.
Right, exactly. So let's look at the sprite. So down here, I do the sprite batch manager draw, right? And then sprite batch manager draw, I'm getting the iterator. Okay, so there's no news here. You know, so if you see a new, like just stop for a second and think about who owns it. If nobody owns it, it's short term. If it eventually gets attached to some manager, it's long term. And what the goal is, we try to minimize the number of short terms. That's, you know, the goal. Or we try to do our short terms in the loading pathway of the project and have very few in the normal update draw. You know what I mean? Because every time we have short-term news, that's an overhead and that makes the application go slow. What's interesting, we're going to have thousands of things moving around on the screen and we're running in debug, right? And that's intentional. You know, this way we have to make sure we're kind of doing things efficiently, otherwise we would make it slow.
And that's something that I was going to ask. Currently in my code, my factory is actually a long term because I'm keeping it inside of the grid. Is that a bad thing to do?
You're not keeping it in there. You have to attach it to something. Don't you have a game object manager, game object node manager?
Yeah, but the factory itself, the object of the factory, I'm keeping inside of the object of the grid just so I can call the add rows of aliens later, and I don't have to create a new factory every time I call a row.
Okay, then just describe it. Say, okay, this is long term. This is where I'm keeping it. That's
okay,
all.
yeah. So
Yeah.
that's
No, you're allowed to do that.
Okay.
I just want you to. This is more of a slow down, stop. You know, too often in Java, in a lot of areas, this is the difference between architecture and software programming. Architecture, we're worried about ownership. We don't want to recreate objects multiple times. Like, it's kind of like here, you know, oh, I want to walk a dog. Well, what if I go to the dog factory? Well, I go create a dog. So they give birth to a dog. I grab it, I walk it. Now when I'm done, I kill the dog. You know what I mean? Like, what kind of evil person is this, right? No, you want to reuse your objects as much as possible. And you don't want to do too much waste. So you're trying to be, quote, environmental and reuse things as much as possible. And that will actually make your code faster.
Okay, it's just because the factory itself, I will just use in the initialization to add the aliens. And
it's the factories are almost always, so right now your factory is used here. Later in the game, when you clear a whole grid of aliens, you shot them all. Now you have to recreate it. So, you know,
makes sense.
Right. And, you know, and if you're doing like onesie twosies, that's okay. A new here or there is not that bad. It's just, if that's your normal process to always create news, now you're getting hit by too much construction of news. And more importantly, at some weird nebulous time, at the worst inconvenient time on Earth, a delete will happen and slow down the whole application. So we want to try to remove the temptation for the manager to use that. All right, so milestone 1, just crank on this and get it going. Label your things as best you can, LTN or short-term news. Give me a grid marching back and forth. Add boxes somewhere on there. Just, and toggle them on and off. That's the only addition, because we just need boxes up there. Don't worry about collisions. If you want to sit there and have it go horizontally so far and then turn around and go horizontally back, you can do that. We did this in one of these weeks. I think we did the move with the iterator, or we
This is
can
the composite move, right?
composite move, right? So then we can have the iterator, right? And so once we have the iterator,
I have a question about the moving. Should we just increase the speed so that they get to one end and the other quickly during our demo?
no, don't increase, have it go at a certain rate, and you can be talking about it, but I just want to see it move to the edge and then turn around, move back, right?
Okay, because
so-
I thought you wanted it full screen for the demo, and so like if we only have like 11 rows, what if we have a wide screen? Takes a while to get there, like past the 5 minutes.
It doesn't take 5 minutes for it to go across the grid.
Yeah, no, you have to set it to
Nah,
the
but-
you have to set it to that special resolution, the
Your
96 by.
resolution over here on the main. I'm sorry.
So do we just, so it doesn't have to be full screen, it just has to be that resolution, the 10,
you do the resolution
I
I said.
896 by 1020 or
Yeah.
something.
Yeah,
If you-
1024 or something.
If you can't handle
Yeah.
that, then you have to do a multiple of that. Sorry. All right, let me get
Okay,
let
so
me get to the lecture and then show you this. Let's start closing some of these down. It needs to start looking like a game, right? Being misproportional doesn't count anymore, right? All right, so here is right. So these guys are here moving, right? And what we want to do is get into the right resolution. Everything's super slow. Weird. Wrong class. I can look all day. It's not gonna be on that class. I'm totally drawing a blank here. I know that
I think it was like 126 or something, if you can search by the number.
yeah, okay. Thanks.
That one. Milestone 1 screen size. Or sorry,
Here.
alien resolution and spacing.
Yeah, so here it is. You want to have this resolution. So this is the actual original screen resolution, right? So if you just multiply everything by 4, you get this. So 896 by this, right? So here is the game. And it was black. All right, so there it is on the corner here. Oh, I figured out how to get rid of that crap on the screen here. Go to properties, and then here it goes. Type of application to Windows. And now you don't get that stupid window that pops up. Or maybe you do. Let's see. There. So they're seeing that little pop-up window that's happened, right? So here's our screen. So my lame ass computer is so bad in resolution. The bottom is like almost not visible. And the way I dealt with this before is that I think I can make the taskbar. How do you move it? I know you can move the taskbar.
You can also hide it.
Oh, really? How you hide it?
Yeah, you right click, then go to this settings.
Taskbar settings. Cool.
Yeah, and it should be right there.
Yeah. Right. So now. There it is. So this is the screen right here. So it just barely fits on my stupid monitor, right? But this is the resolution. So your whole game will live in there, right? If you can't live with that resolution, and like I said, I have a cheap laptop that they gave me since I blew up the other one. My resolution, this is as good as it gets, right? It doesn't do, my vertical lines is 1080, which is really lame. Programmers love vertical lines. So 1080 is what I can go to, and this goes to 1024. So I'm just squeaking it in, right? If I didn't want this, right, I can do this. If I wanted to, I can make mine a multiple of this, right? And so just make this 3. But then you got to make sure you stay with that for the whole rest of the class. So 3.
Well, and you have to redo the sizing for the,
Right, it actually
sprites.
creates a lot of other. Yeah, so you had to redo everything, but if you wanted it just a little bit smaller, there you go. In some ways, this might be a better preferred resolution. Which I hate that it keeps right in there. There we go. Because what's nice about this, stupid taskbar now. Come on. I didn't know I hated that button. All right. What's nice about this is now it's like, here it is. It's the right resolution. So, 3 or 4 times it. If you have a good monitor, you should be able to do 4. My lame one just can't do it.
Thank you. I had the resolution flipped, and so I think that's why it was taking a little bit longer. That plus the marching.
Yeah. All right. So now, if you look at the references, right? So here's like the proportionality. Now this is an actual graph from a game, but some poor bastard measured it and did all this stuff. And I forgot who did it, but a couple of years ago, they also did this. Here's the text file. And this is like so nice of them. He puts up there all his names of things, right? And he literally says, okay, here's his image manager and here's his sizes. So like he actually did the whole cutting out of the texture. So what's nice about this is the image. So this right here is using this TGA. He literally cut each alien out. he doop, 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 cut each one out. And here's his answer. So he saving people like, a lot of BS, because here's all the answers of the images. And those are useful, right?
Just a question then. If my resolution is smaller than that, do I need to resize the?
Well, you
alien
better
sprite?
look proportionally correct. You know what the game looks like. If it looks wrong, you're going to lose points.
And I'm just asking if I should reduce the size of the aliens as well.
What do you think?
Probably yes.
It should look proportionally correct,
Okay.
right? So, so this, somebody went through the effort of trying to reverse engineer and went through each one of these, right? And he was doing his on this resolution, which I agree, because the original one was this. So if you do it by 3, then you're going to have to take all these numbers and divide by 3. And then you got to make sure the offset and everything's right, but it should look proportionally right. It's this much of the screen, so. So there's the screen. And so now all you're doing is this whole grid is going to go from here, hit the edge, turn around, come back, hit the edge, come back, just go back and forth, hitting the edge. Right. And they're going to march back and forth. Right. There's the aliens. Animation swapping is happening so fast, you got to put a timer in there. You control the swapping by the timer. So get your timers working, and that will control everything. I think there's one. Thought I released this, but maybe not. The videos. Did I release all the reference videos that shows you like? Yeah, here they
I
are.
don't think so. Oh, never mind.
No, I don't think I released it.
Oh,
So here. I even linked it up to the top. I forgot to hit release. So this is just reference video here that shows you the gameplay, right? And so some people will contribute, like, here's a good link that shows this. Okay, that link is dead. And you can kind of just see, you want to see the screen. But you see how they're moving? Ignore that they're staggered. Yours are going to be perfectly straight. They all march lockstep back and forth. Let me get you another reference to kind of show you what I mean by that. Let me go off to collision. Oh, cool.
Okay, this is.
That looks good.
Let's see.
That was pitch black.
I know, no, I didn't have the codec.
You could actually use Windows. There's Windows Media Player Classic. You'd have to download it. You can do like any codec really.
It's Justin here doing my
Okay, so here's Justin.
meeting, for animated. So,
All right, do you see how this is moving here?
You'll notice he always does the same thing. I didn't.
Shut up, Justin. Here. Do you see how they're moving?
Yeah.
That's what I'm looking for. So they're perfectly moving back and forth. They're not drifting, they're discretely moving. And how he did that is he has a timer, and dun, 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 whatever that is, a half a second, 0.4 seconds or some shit, something like that, right? Get out of there. There you go. So you can kind of see boom, 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 right? That's what I want to see, just going back and forth horizontally. Is everybody on the same page there?
Yep.
Okay. And see how this is proportionally the right, everything's the right size and aligned. This way now we can start focusing on it. And it's actually, if you notice, the top alien guy is a little bit narrower than the bottom one, and that's intentional, so it's harder to hit. Right. All right, so let's continue on then. All right, so milestone 1, start getting going. You can get there. The big thing here, what I'm trying to do is see that you have 55 aliens on the screen. They're all moving lockstep. I'm seeing that you're using patterns. You're going to show off the patterns. You're going to enumerate the news. And then I'm going to see the pooling and, we just did the priority queue, stuff like that. So a lot of stuff's been demonstrated in the previous milestones. Sprints. So this way you can go through it quickly. And that gives you the ability to go through this very quickly. So the priority queue, you just show the sprite priorities where it's being, I'm sorry, that's proxy. Where's the priority queue, the timer events, and show how it's inserted in priority. So just quickly go to that section of code, show me where it's inserted, and show that how you're putting it into the correct order. That's it. Very simple and easy to use. So just a quick laundry list of this stuff, get through it and demonstrate it. Because then we get to start doing, like, this is all infrastructure, then we start having fun. All right. And hopefully the sprints kind of got us to the point where we feel reasonably comfortable getting through this. So now we're off to the new stuff. All right, so this next problem we're going to go after is, we did the collision, right? We added the objects, we added the hierarchy, and and what we did, make sure I'm totally neutral now. All right, so we added the hierarchy. This is where we last left off, and what we want to do is we added the ability to iterate through a composite. So here we are iterating through the composite doing print, and I would suggest you iterate through the composite and do your move. And I think that's a nicer way to do it than the recursion. Right. So now here's the problem. So now that I know this trick, you go from console, you go to Windows. That's it. Right. So none of that other stuff. All right. So what's happening here is we got to move the, we got to move. We want to update the children before we update the parents. And if we look at it from a tree perspective, we kind of have this, here's a column. And then underneath the column is the 3 birds, right? Right. So this is a composite. I'll make it a square, right? And what we need to do is we need to update these first. And once this whole line is updated, then we update that guy. And this is important that we move the guys first, then we update the box. So let me show you what it looks like when we don't do it that way. All right, do you see how, like, as it just pushes the edge of the box? So follow the green bird. See how it just pushes the box? And see how the red bird is just pushing the box out? And this is all kind of aligned correctly. Now, if I go into the column And the columns here doing the update. And I think I have to go into the game object. Update. Who gets me there? Let's see. Bird grid, column, yellow bird, red bird, that. All right, so I am drawing this. I am iterating it through this in first fit. Okay. So why is this thing working? Column, this iterator. Oh, I'm it's a child. So, I'm iterating through. So, all right, I'm drawing a blank right here. Why this is looking okay right now? Because I need to see which guy's going to hit first, the alien or the.
Maybe it's just happening too fast.
It might be too small of a step too. That's giving an illusion. All right, so go into this. This is yellow bird. Yellow bird's going to hit. Here, let me go back to this line here. Yeah. All right, so here's this. Now I'm going to this. And I'm updating yellow bird. Red bird. Green bird. Then it's going to be column, right? Column. All right, so I am updating.
That's how you update the column last.
Right, so I'm doing this right. So how did I get it on that list right?
Yes.
Oh.
Go to the iterator. Because it should go like the iterator would.
You should go top down. That's
Yeah.
how I was doing it. Yeah, top down. All right. I was saying I did some trickery here and I'm trying to figure out what I did. So here's the bird.
Does it still have the move in the composite?
It's a composite right now.
Yeah, but your move function.
No, I'm not doing a move. Each bird has its own little update move.
No, I know, but I know in one of the reference codes there was like a double move.
Oh yeah. I'm not doing it here. I don't see it. Let's see how this thing's added. Here's the grid. Maybe I'm doing this inside the factory. Red bird, boom, 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 boom. No. I am adding it to the screen somehow. There's my node object. So somewhere I'm adding this. Where the hell am I adding this? Bird, create, factory. Well, shit, let's just step through it. Searching through some. All right, boom, goes into this. Create a grid. Boom, create a grid. returns, puts it, activates the sprites, activates the collision, returns it, still hasn't added to the manager. Now, grid add, so now we're adding it here.
I think you are adding at the front so that it is picking up from the bottom. So,
Or what did you say?
you are adding the objects in from to the front of the list. So basically, it is picking up first the yellow board, then the red, then the green, and later on it is picking the column and the grid.
I'm not seeing the game object manager. Somewhere I'm adding it to the game object manager. Here, let's go. Let's do it this way. Somewhere I'm calling this. So let's just put a breakpoint there.
You're saying you can't find the actual call to attach?
Yeah, to attach. Here, okay, there it is. Okay, so I worked it backwards. I just put print. So let's see who called me. Add component. So the composite's adding it. There it is. So right here is where I'm doing the attachment. So in the add here, I'm attaching it to the parent. So here's my add, and the first thing I'm adding is, wow, I like that I outgeek myself here. All right, so this is adding collision, the column.
I think Shashank is probably right. The
What?
grid is at the end of your game object list, so it gets updated last. So it's picking up all of the previous updates. Just naturally.
I don't see where I'm adding the grid. That's my problem.
Oh.
So that's my problem. Yes, it clearly is, because otherwise it wouldn't be working, right? Oh, wait a minute. I don't add the grid. The grid's not being added. I'm only adding the columns. Okay, totally got it. Now I know why it's working. Just in really nice day. I put this and added this in reverse order. So what I have is this. I have a grid, right? And this I don't even add. First thing I add is this, the column. Then I add to front A, then add in front of that B, then I add in front C. So this gets fired off number 1. This becomes 2. This becomes 3, and this becomes 4. It's just the way I added them. Does that make sense?
Yes.
Yeah, so here's my game object or game node object manager. And the first thing I add is the column, right? And then I add A, then I add B, then I add C. So then when I say update, it's going in the right order for this demo. Not that I like it. So that's how it is. So I'm not actually adding the grid. I'm just going column in these 3. So those are only ones being drawn. All right. All right.
All you'd have to do to show it being behind would be you just pick up the column and add it last.
The grid's not even on there. So
The column is what's
yeah.
the box around it. You can
right,
just
and the
swap the
column
order.
is the last one on the update. The update goes C, then B, then A, then column.
Why isn't the grid attached to the game node object manager?
This is just for this demo because I'm showing the purpose of this demo is to show the boxes and to show the union. That's all I was trying to show in this demo is the union. Right. So so here's the union. I need to update the characters first before I update the column, right? And so that's important. So now that I understand how this was added, I should be able to understand how to fork it, and I fork it by doing the reverse. Here. So now I'm going to do in the reverse order. So the column will be the first one drawn and the rest, right? Just by swapping that order. And it's hard to see, but it's actually one movement to late. The red box is just a little bit outside the blue. So let me see if I can accentuate this. Blocked out the edge. There you go. Right. You can't really see this, but right now the order is off and there's a little bit of an edge. So when it goes up to the top, watch this green guy go up to the top. The red box is a little bit outside the blue box. It's 1 pixel, so you might not be able to get it off the recording. So the reason I bring this up is that we have to control the ordering that these things are processed in. We want to process the children before so like here it is correct. You know, everything's locked up and there's no bleeding over the edge. So what this gets me into this next problem, which is we need to have an iterator that goes in reverse order. So right now, our grid has an iterator that does this. Boom. And then that is. Right. So, all right. So here's our iterator. It starts here and it's going to go down, and then down, across. Then it's going to go over to this one, and down, across, over to this one, down, across, terminated, right? And this is a top down iterator. Everything's cool. What we need is we need this thing to go the reverse order. So we need to process the bottom ones first before we process any parent. So let me just shrink the problem a little more. And this. Right. So initially it kind of does this. Right. So this is the forward iterator. Right. What we need to do is have it where it starts down here and then kind of goes backwards. Process. And so the bottom nodes get processed before we do a top, both top ones before we process that. So we're kind of doing it in layers, right? So that's kind of a problem we need to do, right? So that's going to be this week's homework assignment, you know, like the one you're going to get on Sunday, the new PA, is how do you make an iterator that goes reverse? And if you start to do this, you can add more data. So I suggest you add in your node, you add a reverse, a P reverse pointer. And what you'll have there is you'll have the reverse pointer that constantly pointing to the right location. And when you add, if you add or remove a node, you just correct the reverse order, or you just rework the iterator to do that. So then it terminates. So you would have one where it's going to affect the bottom, then it will do the next, the bottom, then it does the next, then these two are set before we do the next one up. So we start from the bottom up, right? And so that's kind of the new homework or problem assignment we have to do. So I need to just demonstrate this cheap and cheesy, right? So here's how I'm going to do it cheap and cheesy is I'm going to go forward and then what I'm going to do is when I go forward, I'm just going to turn around and make my reverse pointer go the opposite of the forward. And now the pink ones will be in my reverse iterator. There, you know, the homework assignment is to do it cleaner and better, but I want to do quick and dirty because I want to. The exercise is not so much to show this off as next exercise is do the next thing after this reverse iterate. All right, so so here's the grid, and I wish I figured that out earlier than today. All right, now let me show the nodes. So, okay, so here's the reverse iterator, right? So let me go first and show you the forward iterator. Right. So here's the forward iterator. Shit.
You have the
Oh, I got two.
PID.
Yeah, I got two different names. So when you get in name collisions, the quickest trick is to scope it. So there. And now there you go. All right. Shit. What is still? Do I not have this now?
No, I don't think C# agrees with your scoping.
It does.
That was the error though. Was that the
Oh wow. That's all right. Fuck, two. All right. This is such a hack job.
I think
Okay.
if you do if one, it would work, right? Like I would imagine.
All right. Well, I gotta compile. All right. So there we go. All right. So here's my output. Way too much effort to get this out. Right. All right. So here's my thing. I'll forward it. Declare grid, first column, yellow bird, red bird, green bird. Next column, yellow bird, red bird, green bird. Okay. Now I want to do the reverse iterator. So let me clear this. Boom. And now the first one is green bird, red bird, yellow bird, column, green bird, red bird, yellow bird, first column, not grid, right? So I did the bottom up. And the reason why I want this is for my collision, I need to update going the reverse direction. So now when I do my update here, I can change this and basically now do a reverse iteration for my collision, right? So this is just a proof of concept. what I did was cheap and cheesy, and I'm kind of embarrassed to show you, but how do I do the reverse iterator? You have to stop and sit down and think about this some more. But what I did is I did a forward iterator, then I scrolled away the previous, and then I turned around and fixed it and made it a reverse. So basically, I went forward through the whole tree, left breadcrumbs so I can go reverse through the whole tree, and now I'm done. This is not the way to do a reverse iterator. This is totally a hack, right? All right, so all this gives me a reverse iterator. So what do we need a reverse iterator? Now we start the fun stuff. We need a reverse iterator to do our visitor pattern, right? And all right, so visitor pattern. Okay, so the visitor pattern is, I think, the hardest pattern there is. It's a double dispatch pattern. And so here's the slide, and there's really not good diagrams for this pattern, unfortunately, but it's much more, okay, so the problem with the visitor pattern is you have two objects and you want to determine who collided with whom, right? And it's a really interesting kind of problem. And so we tend to use the visitor pattern for collisions. This is kind of a trick. And so here's the pattern itself, which is basically you have one function that says accept, and then the accept says I accepting a visitor. Then I go visitor visit me, this pointer, and then it discriminates and calls the other function. So it's a two-hop kind of scenario. So give you the origin of this and why we're using this is that at the end of the day, we have game object, right? And game object. And these guys are colliding with each other, right? But this might go through a couple layers, and this might be a yellow bird. And this side might go through a couple layers, and this might be a column 0. And all you're given is, hey, game object A collided with game object B, and we need to do some unique reaction for a yellow bird and a collision object. Do something. I mean, a column. So we might have to do some unique reaction to this. The problem is, at this level here, I'm in polymorphism land. I just know I have two game objects. I don't know anything about who's actually colliding. And I don't know which one to discriminate on this. So the kind of thing to do is, how do you determine which node is what? So let me go through some mini demos and just kind of bear with me. I think this will come out in the wash. All right, so here's the visitor pattern from Do Factory. All right, so we have element and visitor. And what we have in there is we have two concrete classes, concrete class 1 and 2. And it has the method here, visit concrete element A, visit concrete element B. And so these things are overloaded. And then on your element side here, it has accept function. And the accept function here. All right, so this is kind of the standard prototypical simplified pattern, which is horribly confusing, right? And how it works is you create your visitors, and you basically go your object structure, accepts your visitor, then your visitor calls the appropriate object reaction. So it's a double dispatch. This is such, hold on a second. I'm just going to board on this one because this one is not clean. Let me do the next one. All right, so I'm going to use things that we can relate to, because I think that one is so abstract you won't see the pattern. So here's the pattern. All right, we have an alien, right? And we have a missile. These two are going to collide, right? And we need to, and all we're going to be given is these two are colliding. We want to know that an alien collided with a missile. Well, the catch is the missile can collide with an alien. It can collide with a shield. It can collide with a bomb. It can collide with the ceiling. It can collide with a UFO. There's a lot of things a missile can collide with. And we need to have a different reaction for each one. So a missile collides with an alien. A missile collides with a bomb. A missile collides with a shield, right? And how they're, a way to do this is to have the first way to do this is to actually have interfaces. An interface is just basically an abstract class, right? So it's an abstract class with abstract methods, and you just have to implement this function called accept. So then the visitor has a pattern that says I visited by an alien. I was visited by a missile. So here's the contracts for this. You visit by an alien, you take an alien argument. Visit by a missile, take a missile argument, right? And these are the interfaces, so you have to implement those. All right, so let's do the missile. So the missile has these two contracts that you have to do. So we do the accept. And the accept function is the double dispatch. And how it goes is this. Some visitor, we don't know who, but some visitor comes in, right? And that guy's called other. Let me go other visit, and I'm a missile. So I go visit missile, and I pass in this, right? That's the thing. You just take the other here, and you turn around and say visit by missile yourself, your name, and you pass in your own pointer. Then on the alien, it's just to say an alien was visited by an alien, a missile was visited by a missile, right? So you put those two in there. You do the exact same pattern here for the alien. The alien, you do the accept, you take the other, and you just go other visited alien, and you pass in your own pointer. And then you also implement the two visit functions. So let's show you this. It'll start making sense. All right, so I create a new missile and alien, boom, boom. And now let's pretend you have a collision system. And at the end of the day, an alien collided with a missile. Dink. Now you want a reaction to it. So, so let's do that. All right, so here we go. Missile is being visited by an alien, right? So we go missile, accepts an alien. So it accepts an alien. So we go in there. And so right now we're in the missile because we were we're missile one dot accept. So missile one dot accept. Right. So we're in a missile. And this right here is technically an alien, but we don't know that yet. So then we go down here and said, okay, a missile. And then so this is your first step. You land in the missile class. And you go other, visit missile. So then the other is whoever was passed into this. And now you're going to dispatch into this guy. And boom, and now you're over here. And now you're in the alien class. But you're not in the, you're in the alien missile, and you take a missile argument. So now you said it collided with an alien. So missile collided with an alien, right? Now we can reverse it. We can say the alien accepts a missile, reacts to a missile. So an alien goes in here. It's okay, alien. Now I'm going to go other, which is missile. So I'm going to missile visit alien. And now it says an alien collided with a missile. So far, this doesn't seem like it's really helping us yet. But what we essentially did was this. Missile, alien, right? And we just said missile dot accept something here, right? We know it's an alien. And inside of this function, you go x dot visit this. Now the x happens to be an alien. So now we're in the alien over here, the alien class. And then we see the visit. So here's the visit function. And it takes in a type missile. And now I know that I am this, which is an alien. And my input argument is a missile. And so now I have these two parameters I can do anything with in that function. So the catch here is I don't know what just came in my doorstep. So I don't know. So I just jump, visit to it, go there, and now I know who it is.
So you're abstracting like the
It's-
acceptance.
Right. It's you're
Yeah.
discriminating between two types, right? So this, so far, still not a believer in this. And then you go a little deeper, right? So let's start adding more options here. All right. So we have bomb, alien, UFO, shield, and missile, right? And now we can collide with any of these. So the catch is I want a unique reaction for a bomb and an alien. That's worth so many points. I want a unique reaction with a missile and an alien. I want unique points or sound effect with a UFO versus a missile, right? So I essentially create the accept. And the accept is always the same. Whatever comes in, swap it and pass in yourself, right? And then you have to sit there and have this discrimination. Which function are you being visited by? A bomb, an alien, or a foe, right? And this word here, visit bomb, is redundant because we have a bomb argument, so we don't need that at all. But I'm just doing this to kind of keep it clear. So let's look at how we deal with this. We create these objects, right? Alien, missile, and UFO, bomb, and shield, right? So we just sit there and say, okay, missile versus alien, and it just lands right here. And missile versus alien goes into missile, then it goes into alien, and now we have a missile collide with an alien. But what if you had them swapped around? Because these two guys can be around. You can have an alien versus missile. It goes in the alien, swap, Orama, lands over there, and it goes to the missile. The same thing here, we can do with a missile versus bomb. Missile, swap, and gets bomb. Or bomb versus missile, bomb, go into it, missile, right? And so we can kind of do these combinations, right? And that so far makes a lot of sense. But let's change this a little bit more. These are all, I don't know, can I do this? That would be too much of a tear up. These are all just game objects, right? So let's go on to the next issue. So what happens when you think about the game, a shield, right, can never collide with a UFO. But I have to do the implementation of this, right? So we get this first problem here, which is the first problem right off the bat is if I define 5 collisions, I have to repeat the 5 collisions in each class. So, so right now, I have to implement these 5 collision reactions 25 times. right? And some of these things don't even make sense. Like an UFO will never collide with a shield. The UFOs at the top of the screen, the shields are at the bottom of the screen. They'll never collide, right? A bomb is going down. How does it go back upwards to hit a UFO? It can't hit a UFO. So we have some problems that they never can collide, and we have a multiplicity problem. So remember, I was very much against interfaces, because you have to keep copying that code again and again, and this is where you can get into trouble. So now, what if instead of the visitor class as an interface, we do it as a virtual class? And what we're going to do here is saying, here's the things: visit alien, visit bomb, visit missile, visit shield, this, that. But we give all these guys a default behavior, right? And the default behavior is really interesting. If this says the default behavior is not implemented, not implemented, not implemented, right? And so we do everybody with the default. Then we specialize with ones that are okay. So a shield can collide with a bomb. A UFO can collide with a missile. A bomb can collide with a missile or a shield. A missile can hit an alien, a bomb, or a UFO, and an alien can only get hit by a missile, right? So what's interesting about this is that if some reason a UFO is getting collided by a shield, there would be nothing specialized, so it defaults here and goes not implemented. More importantly, instead of doing 25 reactions, I have 1, 2, 3, 4, 5, 6, 7, 8 reactions. So I went from 25 to 8, and these are the unique 8 that I need to deal with. And if anything gets through my web of worry here, I can just sit there and it will land here as a not implemented option. So let's try this out. So create the aliens. And so now here, start here. Missile versus alien. This is legal, right? So we can go missile versus alien. So land and missile, pop over to alien, they collided. Alien versus missile. We're an alien, we go in there and we land, and we're in missile class, and we get visited, right? So now missile versus bomb. Well, this is okay. We go in here, boom, right? And missile versus UFO, those will work, right? Bomb versus shield, that will work, right? So far, everything is working as advertised. Now here's the next one. UFO versus shield, they can't work, right? But somehow people called it. So here's the UFO, boom, cool. Now we're going to do other. Now it swaps to the base class, which says not implemented. So now I can kind of catch ones that are outside the realm, right? And the reason why I can do that is that I have default behavior as a base class, and I specialize in the derived class, right? But now let's think about this a little deeper. All right, so in this case here, I have the same kind of pattern, but then I have a reaction, right? So let's take a look at this. All right, so I go missile versus alien, or alien versus missile, right? Aren't they the same thing? Truck drives into person, person runs into truck. There's still, the two are colliding against each other, right? Why do I have to have a separate code on this? So what we can do is this. We can sit there and go into it. You know, here's the first level, hop into the next guy. Now go to our reaction. And their reaction is, hey, the two have collided. So this is the one and only one method, right? Now let's do the other one. Alien versus missile, right? So go in here, do the hop, and then go into the reaction, and here's the same reaction. So this same code gets called, right? No matter if you do an alien versus missile or missile versus alien. And how you do this is kind of an interesting thing. You just need a did I do the other ones? I just did the first one. All right. All right. So how can we clean this up even more? Is that, do we really need to do unique reactions? So if you think about it, an alien is colliding with a missile, or a missile is colliding with an alien. In the previous release, we have a reaction. And then we have a reaction. So we have the same reaction, but in two locations. And that's not dry. You know, the dry principle, which is don't repeat yourself. So dry is D-R-Y, don't repeat yourself. And what this means is just have one implementation. Don't have an implementation here doing square root. And then over here in your code, you have another square root. Right? Have one and have your code always go to that one function. So you can fix the bug in one location. You can put a prints in one location. You can optimize one location, and everybody benefits, right? So what we have with the visitor pattern is we say, hey, you know, A versus B, and this turns out to be missile versus alien. And here's a reaction. Then we can also just have B versus A, and this is alien versus missile. And we have a reaction. And if on the surface that seems okay, but when you think about it, a missile and alien collided. A missile and alien collided. These two reactions have to be the same. Otherwise, you have you know, skewing behavior between the things. Did you collide object A versus B or B versus A? They should be the same reaction, right? So what you have is the reaction should always be the same. So the trick is you can put your reaction somewhere else. We'll just put it over here, reaction, right? And your parameters in your reaction, I just go in alphabetical. I'll go alien and missile, right? I always go in alphabetical order on the parameters. So here, I'm going to call reaction, right? And this, comma, missile, because I'm in the alien class. And here, I'm going to go reaction. I know it's an alien, so I'll go alien, this. And this always alien, missile, and these both will then shoot to the same function. So now I'm dry. So what does a visitor pattern get you? It will discriminate to two functions. Given two base classes, I can discriminate to two specific classes, and then I can do something when those two classes are connected, right? You know, in my case, it's a collision. It might be something else. But because these game objects are unknown, you just have a list, right? You just might have, but here's a list of game objects. You know, so here's game object. And you're saying, okay, take these two, call one A and call one B, do the collision, A versus B. And now you find out, oh, wait a minute, it turns out to be an alien versus a missile. Now do the reaction to that.
But like, if you scheduled some action due to the reaction of alien versus missile, but you still call it twice.
No,
So you'd end up with like, Well, the alien collides with the missile and the missile collides with the alien, and then they call the same reaction. But like, if you went and like put something on the timer queue, like the image swap for like the starburst or whatever, wouldn't that end up in the queue twice doing this?
No, you're only gonna do one collision. You just don't know how the orders are. You don't know which order is what. I'm just saying, you don't know.
Oh, okay.
I'm saying
Got it.
you're at two base classes. You don't know which two classes collided.
So where you were showing the examples where it's this except that, then this
Mhm.
one except that, that's not what you'd actually do. Either the alien collided with the missile, in which case you'd call A dot this, or the missile collided with the alien.
Well, no, you don't even know that. You just say base class object A, base class object B collided.
But
Don't
you
know-
only call the except once.
you only call it except once. The problem
Okay.
here is you might get the ordering swapped around. You can't necessarily guarantee the trees are going to be multiplied or communicate together in the same order.
Yeah, no, that makes sense.
So it's better to sit there and say, okay, I should have the same behavior, whether it's A versus B or B versus A. I don't even care who gets called. It will always have the same behavior. And then on that behavior, we're going to actually have an observer. So, what we're going to have is this. So, here's the game object. We don't know anything about this game object. We just know it's a game object, and there's a couple more classes, and then here it is, alien. And we're going to have another game object. And this might have, and this is missile, right? And then we're going to basically say, hey, these two game objects, because we're doing, we're going to be comparing our collision systems is going to work on the base class. So we're just going to go collide A, comma, B, right? So this is B, and this is A. And this collision is going to internally go A dot accept B, and then that function fires off, and then you're going to B's class, which is saying B visited by A. Then you're going to go, okay, then you're going to say reaction A comma B. So we don't know which ones we're colliding with. We just know, hey, there's two guys that are colliding. No matter who it is, we say it's collision happened. Yes, true. Then call the accept. The accept will jump us into the B object, the visit. Then we can do the reaction to that combination. But what if I just had my trees in the reverse order, right? And my trees in reverse order. So I had, these in the reverse order, right? All that would mean is B, comma A, right? Now my code would go through B dot accept A, right? And then I'm in the A class, and then I say I was visited by B. Then I go, okay, I know what the A class is that's I'm in. I know the input. I just do my reaction by order. And I'll just sit there and say A comma B. So I call the same reaction, whether I pass in A comma B or B comma A.
So I had a question. Why does it matter, like determining what's colliding with like what? Like I don't. Why would the order matter?
No, the order matters.
Like,
so I have only one reaction.
Yeah, I mean I get that, but I'm saying like
That's why the order matters.
I'm
The
just
order only matters is to make sure it calls one reaction. There is no concept of ordering. A person runs into a truck or a truck runs into a person. They both hit each other. You have to do something, right?
yeah.
What do you have to do? Well, kill the person, damage the truck, add explosion, add points.
I mean, I understand that it works, but I don't understand because when you have two objects colliding, there's two objects colliding. You know what I mean? It's like, why is there two different functions? I just don't quite understand that.
No, I'm saying you don't know which order the trees are going to be colliding against each other. So,
Okay.
so we're almost there. So like what we're going to have is this. Here's the grid. The grid, right? The column. Alien 1, alien 0, alien 1, alien 2. All right, now here's our aliens. Now we're going to go collide against a missile, right? So we go, these two collide, right? We're not at the leaf node. Go fish again. Call a collision now on these two. Call a collision on these two.
Oh, that's why. Yeah, that's why the
Yeah.
order matters, because one's going to have a tree and one's not.
Or there'd be two
Mhm.
trees, right? You might sit there and say alien tree versus shield tree,
Mhm.
right?
Yeah, that makes a lot of sense, because then they have different nodes, so it's not trivial anymore.
Right. And so if you can handle that these are just two game objects, then everything clears itself. You never have to worry about it again.
Thank you. That was very good. Thank you.
Yeah. So all right. So this is where we're going, right? The visitor pattern, right? But before we get into that, let me show you why we're using a grid and collision system, right? All right. So let's look at the game, right? And just to make sure our nomenclatures are the same. These are aliens, right? And right. So these are aliens. And there's 55 of them, right? So it's 11 columns, 5 rows, right? These guys drop bombs, right? So bombs go down, right? Those are aliens. Then we have shields. And there's 4 of these. Right? Shields. Aliens. We have a UFO. And it goes across the top of the screen. It can go from the right or the left. We have a top wall. Oops. We have a top wall, right, left, and then bottom. The player or the ship is on the bottom, right? So that's kind of all the pieces in this game, right? So let's do a collision system on this, right? So we do a collision system, we start going, okay, well, there's 55 aliens, right? There's 1 missile. There's can be up to 11 bombs because each column drops a bomb. There's 1 UFO. And there's 4 there is 4 shields. Each shield is broken up into 7 columns and by 10 bricks. So it's 70. So this is 280 bricks. Right. So if we add this together, we get 353 items on the screen. And they can collide with 353. So that gives us 1,200. My writing is horrible. 1, 2, 4, 6, 0, 9 collisions. So 124,000 collisions that we have to compare every single update, right? So now Like, okay, but what if we added rules to this, right? Because come on, a UFO is not going to collide against a brick, right? So let's add rules, right? So here's rules, right? And so the rules are alien. What can an alien collide with? It can collide with, there's 55 aliens. It can collide with a missile. 55 aliens can collide with the two walls, right? 55 aliens can collide with the shields, so 280 bricks. And 55 aliens can collide with one ship, right? So this, when you multiply this together, is 15,620, right? Now we look at it from the bomb's perspective, and all I'm doing is just putting rules on this game. There's 11 bombs times one missile, 11 bombs times 280 bricks, 11 bombs times one ship, 11 bombs times one floor, right? So this is 3,113, right? Then we have missile. We also have UFO. So UFO, I know I'm missing some here. UFO versus two walls. And then UFO versus the missile. Right, so there's three. That's kind of was pointless. And we have a missile that can hit the shields, because we already did a missile versus aliens. So missile versus 280 bricks, right? 280. So when we add this up together, now we have 19,016, right? When we added rules, right? But now let's look at it from a hierarchy standpoint. If here's our grid, here's our columns, then inside of each column is your aliens, right? We have a grid. We have 11 columns, right? And then each one can have five aliens, right? All right, so how do you collide with this? Is, let's say we have a missile, right? Here's a missile. The missile collides with the grid. If it misses the grid, we stop colliding. Then it could make the grid, but it can go between it. You know, it can go right between it. So it misses the columns, we stop colliding. It hits a column, right? Then we compare against the aliens in the column, right? So when we kind of do it from that perspective, we have one missile, right? And it can hit the column. So there's one. It can hit the grid. That's 11, right? And then it's going to hit one of these columns. Then there's 5, right? So, so this is 17 now. So alien versus missile. So there's 17 times one missile. And just because of hierarchy, we reduced it from 55 to 17, which is like a good thing, right? And then we have, you know, so maybe the better way to do this is this. We have 55 times one missile, right, is now 17. 55 times two missiles, I mean, two walls, is now, so the walls, right? When we collide with the walls, we're really only colliding with the grid, We don't need to go any further than that. So it's 2. And then we have alien versus alien versus the bricks. So 55 times 280, right? This is the bricks. So now we look at the brick. The brick is a hierarchy, right? And the brick is 1. Then we have 7 of these, 7 columns. 7 columns, 1. And then each one will have 10 bricks, right? So it's 1 plus 7 plus 10, right? So it's 17, 17, right? And that's against screwing this up. Oh, and you would have to on your so the first thing we would do is we go 1 for the box of all the shields, and then we say which one is in here, so it's 4 to determine which shield box are we in, and then which column in this. So this is 11, 12, 10, so this is 22. So it's 22 collisions to do a shield, right? So the shield's like this. There's 7 columns, there's 10 bricks, and there's 4 of these. So here's the 4. Here's the one that goes around everybody, and here's the 7 columns, and then 10 bricks, so 22. So so this becomes 22 times 17, right? And then we have the 55 by 1, which is the ship. So this becomes just a 17, right? And then we start doing the other guys and do the reduction for everybody. The bombs don't give us any reduction. The bombs would be 11. Oh, I should have done it here. 11 times 22. That gives us a reduction. This becomes 17 times 22. This is 17. This is 17. Oh no, this is 2. This is 2, and this is 17. No reduction there. And then this one right here becomes 22, right? So if I sit there and do all this again, 11, 11, 11, 3, right? Add this up, I'm going to get 7, 10 with hierarchy. So here's kind of the Reader's Digest of this. We have 124,609 raw. When we add rules, we get 19,016 with rules. Then when we add rules and hierarchy, it goes down to 710. Right? So now we have to do 710 collisions at the maximum per frame per update. It's a lot better than 124,000. And this is why we're having the hierarchy. Does that make sense?
Yep.
So it's pretty stunning how it just reduces, right? All right, so let's now put the collision stuff into action. All right, so the first thing is we talked about the union, right? So let's look at the rectangle. so collision, rectangle. So in the collision rectangle, we had a union and we have an intersect, right? So the union was pretty straightforward. What's cooking right now?
Aren't the collision and sprite box rectangle always the same?
Same, what do you mean? For each type of alien, it's the same. But each alien has a different size box. The
Yeah.
columns are different sizes.
But the
As
game
you-
object keeps both.
Yeah,
And then you'd have to update both and
what do you
you
mean
mean
both? What do you
both.
mean both? Sorry, I'm getting a,
so there in the game object, there's the collision rectangle and then there's the sprite box. The sprite box has a rectangle inside of it.
right, we're gonna use the sprite box as the collision rectangle.
Okay,
They don't
so we are
have
gonna
to-
reuse that. Got it.
Yeah, we don't have to use that information. We're
But
gonna
then
use
you'd have
that
to
as-
update 2 rectangles instead of just 1.
Well, no, we're gonna actually have a separate rectangle. We're gonna initialize it with the box. We're gonna keep them still separate.
Okay.
So the collision box has no collision box is what you want visual on the screen. We're just gonna use the same size as the image,
Yeah.
just because it's like, why not? In some games, you don't do it that way. So in some games, you have the concept of, like, let's say here's your car. Right? And you have an antenna, right? A little antenna. Well, if you sit there and go by that, then your collision box is this, right? So it's kind of silly, right? Where you really want your collision box being kind of the meat of the car. So a lot of times you don't use the image, you have a collision box that is what you want as gameplay and what you want as reaction. You don't put every graphical artifact on it. But it turns out for our game, here's the alien, and here's the sprite, or the image size or sprite size, right? We're just gonna make our collision box exactly the same size because that's good enough, right? We're not gonna hedge it in or hedge it out. But I just want to tell you that the collision of boxes can be separate. So on the game object, we have ownership of a collision object. And then on the collision object, it has a box sprite. And then the collision rectangle. Right. And when we initialize it, we're going to take the data from here and then copy it into there, and then but keep the two guys separate.
Okay.
All right. So union, we take A, and then we take B, and we just create the union of that, right? Then if we have another box over here, C, now the union will be encompassing both of these boxes. We only do 2 boxes at a time, and that's the union. The collision turns out to be very easy because, here's our object. Does this box collide with A? Does box B collide with box A? Well, we just take the rightmost edge of A, and like if it's over here, trivially reject it. Likewise, if box B is over here, we take the furthest left. If it's this way, we reject it. So we can kind of go around the horn and do this, right? And so if everything is not trivially rejected, then by definition it collides. So we're basically checking the parameters. and saying, is our box that we're testing, say like this box, it's not trivially rejected, so therefore it's colliding. This box here is inside of it. It's not trivially rejected. So we would try to trivially reject. So is it below the line? Is it right of the line? Is it left of this? Is it above this? Is it, yeah, that's it. It's four checks. And so that's how we do the collision. Because we're not rotating or anything else, this collision becomes trivial. So here's the union. We showed you that. It's just growing that out. And here's the collision. And basically just check the trivial or reject. Is it greater than the max? Is it less than the max? Go through the whole check. If it's trivially rejected, that means it didn't collide. If it's not trivially rejected, then it has to be a collision. So we say it's true. That's it. And so that's our collision, right? So now let's do see the visitor pattern in action. This is kind of the aha moment. Okay. All right. So what we're going to do is add game object. So the game object, we're going to add off of the component a visitor class, right? And this visitor class is going to have in it the accept. Here's the accept function, right? So this is the contract. You have to, every class has to write an accept function, right? But here's all the things it can collide with. It can collide with a grid. It can collide with a column. It can collide with red bird, yellow bird, green bird, right? And again, this word visit white bird, this is redundant. You don't necessarily need that because the signature is unique, right? It's just there to be a little more descriptive, right? So basically we put all default behaviors in the base class. So in here, boom, here's all the defaults of everything they can collide with.
If you only had the difference in signature, would
Mhm.
your accept method be able to be virtual too? And just have or not virtual, but like just be implemented? Because it would be
you need a
the thing on the left.
you need a default
visit
behavior. You need a default
this.
behavior, and the problem is they have to be discriminatory, right? They have to be unique.
Well, not if you had the visit with just the difference in the signature based off of the item type, right?
Right. So what I'm getting at is here is that you could get away with just killing the word visit. I mean,
And then
group.
you could have a default, or not a default, but like an actual implementation of accept here. Because it's,
I would have to think about that, see if that would work. I'm not sure. The thing is, this part right here needs to be unique, because you're overloading it, right? If you had this as another, call visitor,
oh, the compiler would reject it,
Right,
even
yeah.
though we know the types would be fine.
right?
Yeah.
So that's the thing, but I'm saying you don't have to have the word group or column there.
Yeah.
It will still work because the signature is unique, right? All right, so this is the default behavior at the base class. I don't know why I keep clicking that one. So now that means every child off of this has to now implement the accept in the visit. So white bird can be, it has to overload the accept. It has to do this. And then it has to, it calls the visit by the visit function, and then it implements any visit functions that it receives. In this case here, it doesn't receive anything. The red bird has to do the accept, and it goes, okay, but it can be visited by a missile. So I do a missile reaction. And then, do the yellow bird accept, and it can be, here, and it just, we can kind of fill this thing in, right, as we go. So let's take a look at this thing in action if I didn't break anything. Right. This one here. All right, so here we go. All right, so I need a way to talk about the collisions, and I need a way to say what happens when the two collide. So where's my rules, right? So I need rules. I need rules that a missile versus alien, right? So missile versus alien, that's a rule, right? And so what does this do, right? This is my rule. I need to hold my rules somewhere, and I have to collide the respective trees. So I have a collision pair. And a collision pair is, here's the name of the rule, collision pair. This name is bird versus missile, right? That's my name of the thing, right? Then I sit there and say, what am I colliding? I'm colliding tree A versus tree B, right? Tree A versus tree B. What's my tree? This is the first node of a tree. So all my collision objects, right? So let's look at it here. Here's my grid. So game object node manager, right? And what it has on here is a node. And so here, and then this is, I only attach one to the game object manager. I only attach one. And this will be the whole tree. So I would attach this, and this would have the root, right? And then I would have, so let me show you how I attach this. Game object manager right here. So I'm going to attach the grid. I'm going to attach the grid to the tree. And so what I have in my grid is my grid has one column and 3 children there. So my grid looks like this. I have one grid. And just for this demo here, I have one column. And then I have 3 children, right? So alien, right? So this is, red, yellow, green, birds, right? So I have some birds there. Let's see what birds I have. Red, yellow, and green. Okay. So that's my grid. And what I'm going to do is on my object manager, all I'm going to attach is just the top guy. So now everything is still on this tree. All I'm going to do is associate the next one, the first one. Then what I do for my missile, everything has a root or a grid, a top node. So here's my missile. I create a missile group, and underneath it is a missile, and I attach the group. So just to keep things symmetric, I'm like going, okay, well, I have a missile group. And this is the one example where you don't really need a collection because it's just one missile, but to keep things symmetric, I do it that way. And then we have a missile, right? And this thing would be the top would be the the shield, right? And then the columns and children underneath the shield, or the, you know, or the bombs, you know, everything has a group. So now on this guy here, I add it to the tree. So this is what's on my game object manager, these two nodes, right? So my game object manager has this, create the missile group, create the missile, take the missile group, add the missile to the missile group. So the missile group is a composite, right? So I add it, create the factory, create the grid, take the column, add the column to the grid, add the birds to the column, and now take the grid and attach it to the game object manager. So now I can go to the game object manager and just do a dump on this. And what I have here is just two things. I have the bird grid and the missile group. Now underneath that is a whole tree, right? Underneath this, the whole tree, but all I have is these top two nodes on the list, right? So now I want to put it into my collision pair. So I get my collision pair manager, once again, create a collision pair manager. So the collision pair just has the name, the trees, right? This is in a whole manager goo, right? So what I have in my collision pair manager is when I say add, where is it? Somewhere in here. Add, I say, okay, what name is it? It's a bird and missile. And I go missile group and grid, right? And I do a dump on that. So let's clear that screen there. Okay, so now boom, and there it is. And so all I have is one guy on the list, bird and missile, right? And all it has inside of its data is a missile group pointer, a grid pointer, and the name. That's all it has, right? So what is the collision pair? That's the rule, right? That's the grouping of the rule. So now inside of this, it has one function, process. And what this is going to do is it says, just collide these two trees. So this is going to go in here and collide tree A and tree B. Then it's going to go through here, collide. When they hit, they call accept. And then we react to the accept, right? So let's take a look at this. So the first one is group and missile, right? All right, let's go through this. So here's my collision. So let me get rid of these prints. And this is also why printing is kind of cool. All right, so here's my process, ready? So I just updated everybody. Everybody's been moved in the correct position. Oh, let me show you what it looks like. Boom, and it hits, right? So at first it's going. Boom, it hits, right? So now let's kind of follow this out. So the first time through this, it's going to hit the collision process. And okay, so it goes, okay, collision process, it's a singleton, get it, go through iterator, collide everybody who's on that collision pair manager, go through the iterator, convert it, boom, collide tree and A. Tree A is missile and tree B is bird, right? So we go into this. Shit, I forgot to miss the step. I'll get back to it. Right, here we go. All right, so we're into this. And the first thing I do is I'm just going to, okay, let's do a collision. So I go into this, grab the trees, walk in there. Okay, you know, for tree A, for tree B, Go in here. Okay, I'm going to collide these two guys together. So I print this out. It says this is the collision I'm working on. I'm working on missile group versus bird group. So then I get the respective rectangles and I call intersect. And here I do the intersect, checked it, boom, 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 boom. And it goes trivial, reject, false. Come out of it. It failed. Go to the next one. There's nobody else siblings. There's nobody else in the tree. I board out of the function. Okay. So no collision, right? So this keeps going on, right? So I keep doing this and what will happen is I'll put a breakpoint here when a collision started, right? So let me get out of this. Boom. So there's my collision, right? So first it's going through here and it's like, no, 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 hit, collide, right? And what did I collide here? I collide with a missile versus a grid, right? So now let's do this. So it's a missile. So we've got missile group. Then I have missile, right? Let's give this different color. Right. And now on this side here, I have grid, column 0. Then I have aliens, right? And we'll get the name of the aliens in a second. All right. So here's my first two collisions, missile versus grid. So I'm doing this. This is my first collision. This is my number one. So this collides, right? And I'm just checking those two boxes. It collides. So now I'm going to say, okay, node A, which is group, accept B. I don't care which order. I just have to do A order. So I just A versus B. So accept. So I'm A, B. So I'm going to go to A's object. Boom. Now I'm in A, which is missile group. Accept visitor, which is grid. And I swapped it. So now I go grid visited by a missile. So I go boom. And now I'm in this thing. I said I collided. Cool. So I collided these two, right? Now what do I want to do? I'm going to do my reaction right here. And so what I'm going to do, I'm going to now say, hey, I'm not on my lowest level. I'm not on my leaf versus leaf. So let's keep going. So I wind up saying, give me the child of my forward iterator. Which one is this?
Looks like a static instance, right?
Yeah, I'm saying, let's just see where I have this. I lost my stack already. There we go. So get child. So I already have this pointer around somewhere.
I mean, I think it's just getting the child of like what you're putting in there, right? It's just a static.
Oh yeah,
object.
yeah. I'm sorry, you're right. It's a static method.
Yeah,
you're
that's what I was saying.
absolutely right. Yeah,
Yeah.
yeah. It's right. It's a static. You are 100% right. Good observation. You're doing better than my memory. All right. So so I get the child, right? And so this child comes across here. I go, okay. And I go, all right, get the child. And so now I'm going to go down. I'm going to stay at the missile, but I'm going to go down one child, right? And since I'm in the bird grid, I'm going to go down one child, so I'm going to go bird column, right? So now I'm doing this. All right, get the child. And now I'm going to say, okay, call a collision between these two guys. Right? So I'm going to call collision pair, collide, and here's the two guys I want to collide with. So I go right back into here. So I'm recursing into this. And now I go through this and like, okay, cool. and now I'm colliding with missile group versus bird column. I test the collision. It collided. Boom. Now I go and accept. Now I'm going to go into visitor pattern again. Now I'm going to go dive into this again. So I'm going to go missile group with column. Boom. So now I'm in the missile group versus column. Presto change to other visit. Boom. Now I'm in column for visited by group. I collided, so print that out. Now go down a child again. I go down a child, and now I'm going to collide with the green bird. So I'm going to collide with the green bird. So go into this again. And now I'm colliding with missile group versus green bird. Go through the intersection and true, cool. Turn, cool. I accept, so now I go into this. I'm a missile group being visited by a green bird, presto change show. And now I go here to my iterator. I go, is there anybody else? So now I'm in the missile. I'm in the green bird trying to get the child. And oh, I'm going now down the missiles pathway because I know I'm in a missile group. So I'm going to go down one level of missile. So cool. And I'm going to go against green bird. So now I'm going to do this one. Number 4. So I'm going to go down to this one, the 4. Right. And now I go back into the collision, do the test. So now I'm going missile versus green bird. Check that intersection. Like boom, boom, boom. True, collided. Okay, cool. Now do an accept. And now I'm at the last level. I'm a missile versus a green bird. Go here, presto changeo. Here, collide, done. And now I can do a hit, whatever a hit is. What did the hit do? Just reaction to it. And that's how I can check this. So I'm walking down the tree. So now when I'm done, it breaks and returns, breaks and returns. And I'm doing nothing, I'm not removing it, but that's pretty much a collision, right? So I'm going to start at the top and then kind of walk and go down these nodes until I hit something, right? But what if I change the order of green, right? Because we see it, so let me go back to the graphic, right? Green's the bottom bird, right? And just fortuitous, that was the first check we did, right? And green. What if I sit there and put green on the list differently than red and yellow? So I have them in the same location, but I put on the list differently. So this goes like right now, it's this one. It's green. The top bird is red, right? Top bird's red. Okay. Right? What if I swap this order here and I have it on the tree as this is red, yellow, and green? What if I put it in this order, right? So I get rid of this order and I swap it, right? right, so now what if I change the ordering of this? And it's going to be this green, red, yellow, right? So what if I had my tree in this order? Well, let's do that. So we go here to the game. And the order that I'm doing this, if I just do it in a reverse order, all right, so I'm just attaching onto the tree in the reverse order. And what I effectively did is just swapped the ordering around. Right. So so let's take a look. Graphically, it should look the same, right? Right. But let's look at the collision now. The collision is a little different. So now what it's going to do is going to do missile versus group, missile versus column, missile versus red bird. That missed. Missile versus yellow bird. That missed. Missile versus green bird. That hit. Right. So now let's look at it this way. So we're doing this, right? This. It missed because we're the collision. The green bird's at the bottom, right? Then it's the yellow bird. Then it's the red bird. So this is the ordering of the birds. There's the column. And then there's the grid. Right? So we're still going to collide with the missile, still going to collide with it's still going to collide with the green bird, but because it's on the tree in different order, I collide with the first child of the column, which is red. That's going to fail. So then I go down to the next child. That fails. Then I go to the next child. That hits. Then I move down one. And then I collide with this one, 6. Do you see how that works?
So I was wondering, so is there one thing, would you ever want to sort in the tree
So
based on?
So this gets into an
Yeah.
interesting question. It seems like on one level, you want to have the children, which is, you're absolutely right. You want to have the children of the aliens sorted from the bottom up, right? And this would make this more efficient, right? Because really what we have here is this. Here's your column. And you have alien, 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 right? So it makes sense to have your column here. And let's just give this A, B, C, D, E. And you really want A here, right? B, C, D, and E. Cool, right? So when you're colliding a missile versus it, right? This will be the first guy you try, which makes sense. And then let's say this guy's deleted. The first one you try is B, right? Because when you delete it, that's deleted. So the first one would be B. This makes a lot of sense, right? But you also have a bomb coming down from the top. So now you're going, your first collision will be E. So on one level you win, but then the other one you're
Always start
there.
from the top? I
What?
thought the bombs came from the aliens. No?
Yeah. Oh, I'm sorry.
Okay.
I'm sorry. No, you're right. This is for the aliens, right? I'm sorry. I'm sorry. I was thinking about the you're absolutely right. Okay, this makes sense to have it in that order for your alien,
Yeah,
right?
that's
But
mainly what I was
now the
meaning, yeah.
shields is another story. So here's your shield. Right? Here's one column. And you have 10 bricks, right? So you'll have shield, column 0, right? Then you have bricks. And let's say this is A, all the way through, K or whatever, right? And well, this makes sense for the missile, right? Hey, you shoot at A first, but when the bomb, which I was, you guys are right, here's my bomb coming down. Well, then if I hit it this way, K is my last one. You know what I mean? So in this case here, which way do you go? Who's shooting at it first, right? Who's blowing up the shield first? Well, it turns out if you play Space Invaders, most of the time it's the human shooting a missile through the shield. Once in a while, the bombs delete some, but proportionality wise, it's probably 30 missile shots to a shield versus every one bomb that hits a shield, right? So I would still bias it A through K on probability, right? But if you're a psychopath, awesome, geeking this out, you might sit there and say, when I collide against a bomb group, I start with my K and go that direction, but that's going to complicate things quite a bit.
What about our reverse iterator? Can't we use that to solve that problem?
That starts at a node,
Yeah, it starts to know,
not
but
the top. You'd have to like have a partial reverse iterator from.
this is one of those trade-offs, like, is the additional complexity and potential bugs worth the insanely microscopic win?
Okay.
What I mean? I would say no. Or go with this approach, get it working before you get clever, right? So that might be a better approach, get it working before you get clever. All right, so this is kind of the collision system. So we have visitor pattern. You can see here, it tries red first, then it goes, nope, then it failed. All right, I'll try yellow. No, that failed. I'll try green. Yes, that hit. Okay, now go down the missile, another line. But then this whole ordering changes is if I change my initial collision, my initial game, when I create the collision pair, if I just swap the order of these two guys, now that's a totally different, ordering there. I'm going to, walk down my grid first before I walk down my missile first. So just by swapping those two orders. So this is why we need that symmetry with this, right? So this is the first thing, right? Just detecting a collision. And right. So the next thing to do is we need to start, doing more things with the system, exploring more things in this. So one thing is we want to, I don't think I got enough time to go into an observer pattern. We want a font system. We want to display the score, display the number of lives and stuff like this. So how do we do a font system? Well, there's a I think I forgot a piece. Seven. Yeah. All right, we want to put a font up there, and the font. I'm running out of time. All right, so we want to create a font. There's a tool here that you can create a font, and oh Jesus, let's get this message. Wow. All right, this is really old. All right, I'm gonna bail on that for right now. All right, let's talk about the what happens, the next thing that happens. Let's talk about the observer. So we're gonna start talking about observers. All right, so an observer, all right, is that I had there. All right, so observers, so what happens when the two collisions hit, right? So we have this, we have the collision pair, and all the collision pair has is a name, then it has a reference to a tree A and a reference to a tree B, right? So now these two guys collided, you know, and in this case here, this is a missile and this is an alien, right? Tree. Those two collided. Now we want to do something with it, some kind of reaction to it, right? So the thing that we're going to do next is an observer, the observer pattern, right? So the observer pattern is a really trivial pattern. It's one of the most popular patterns. Right, so here's the observer pattern, right? And so let's talk about the observer pattern. This is a little bit, you know, this looks more complicated than it really is, right? So observer pattern has the classic case that you see in a lot of patterns, which has a contract or a base class, right? And the base class has this function called abstract notify, right? And then you derive from this and you overload notify, right? And what this has is you have over here, oops, go into a color. I really wanted a different color, like blue. Subject. And the subject basically holds, the subject is going to hold your, it's going to hold a linked list of these. Of observers. And in here, you're going to hold the state. Right. So whatever the state is, well, if you have a certain XY, you have, the class, class pointers, whatever you want to do, there's your state. And so the idea is that this class has a pointer back to the subject, which holds the state. So if it needs access to, hey, what object or what color or what's their value, you point to this thing and get the state. And so in here, you're going to do an event and you have access to the state of the subject, right? And so what's going to happen here is you're going to call, for every element for all of these guys here, you're going to call the notify, which calls this, and then this is going to trigger off these events. So we have it kind of go in the full circle here. We have a collision pair, right? And then we have hanging off of this tree A, tree B, and then the name, right? And then we have subject, right? And then hanging off the subject, we have a collection of abstract notifies observers, and then the concrete. And then this has a pointer back here to have the subject. The subject can even go to there. It doesn't, but it lands at the subject, and the subject can even go deeper into this. Okay. All right. So what does this mean? All right. Let's just think about an alien versus a missile, right? So here's your missile, and here's your alien, right? They have the collision boxes, and the two guys collide, right? So what do you want to do when an alien versus missile happens? Let's just list off things you would want to happen, right? You want to, add alien, points, right? Add to the score. So we'll go this way. We want to do add score. And then this is, this might be a red alien, red score for red alien, right? What else do we want to do? We want to delete missile. We want to delete alien, right? We want to add sound. Right? Add splat. Remove splat at time. Right? So these are everything we want to do when a missile hits an alien, right? Or an alien, or an alien comes down onto a missile, right? We want to add the score. We want to delete the missile. We want to delete the alien. We want to play the sound boom. We want to add the explosion splat, which kind of looks like this, boom, right? Then we want to add to the timer at a certain like, half a second later, remove the splat. And then we need to have the contact point, to drop the splat together, right? Oh no, the splat would go where the alien was, sorry. So it's going to go in the center of the alien. Right? So these are all the things you want to do. And so what you do is you basically sit there and say, okay, these are all observers, right? So this is your add score. Then you have another one. Remove alien. And you have another one. Right? Add splat. I'm not going to put them all here, but you get the drill, right? Play sound, right? And so now all these are linked together. It comes off of the subject, right? And then here's your collision pair. Right? And then you have your tree A and your tree B. So what happens is here is, a notify function, right? And so when the collision, you do your whole collide, and you collide your trees, A comma B, right? At some point you get down to it and it says, you get down to a certain point, dot, 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 arrows, right? And then you get down to this thing that says, okay, red bird collided with missile, and there's nothing more. At that point here, you go, okay, call the notify on the tree, on the collision pair. dot notify. So it goes wonk over here. Then this jumps into this notify. And this is going to iterate through all these guys. Boom, boom, boom. And it's going to go here and goes, fires off the notify here. Right? And then notify there, notify there, notify there. Because all these guys are sitting here just waiting to be triggered. Right? So these are called observers. You'll see also a term sometimes used, listeners. They're listening for an event to happen. And somebody's going to trigger that event. And that's where our collision system is going to call notify, and it's going to trigger the event. And then everything that's on this event gets reacted to. So they all get fired off and they stay on the tree. So this tree has an attach, listener, and it also has a detach. And this attach and detach, generally speaking, you load it up and you leave them there. And every time the event happens, you fire off all these things. So you hit another missile, all the things get fired off. Hit another alien, all these things get fired off, right? Add to score, well, you can point to the subject. And in the subject here, you say, oh, by the way, I'm PA, which is my alien. And my PB is my missile. And now you can sit there on the notify and say, call alien update score. And this way, the red alien has different points than the green alien, which has different points than the yellow alien. Right. Here, the remove alien, you're going to now go over and do a function and call off and remove it from the tree. Right. And you go to your subject to get what missile is being removed from the tree. Add splat, you're going to then go to the splat factory and add the splat. Or if you have recurring graphical objects, you go to those recurring manager, you grab it from the manager and reuse it. Play sound, you call the sound system to play the sound. And all this crap happens every time a missile hits a bird. So this is the observer listener, right? This is the rules to the game. This is the behavior of the game. And what's really interesting as we move forward in this after milestone 1 and you're into the collision system and you're into the visitor system and stuff like that, you start to realize majority of the game is setting up the right items to collide with, which collision pairs you want, adding the right observers on there to react to what happened. If it updates the score, if it puts itself back on a timer, if it adds a timer. So like the whole idea of remove a timer, you add the splat and then you add on a timer, 5 seconds later, delete that splat. So it removes it automatically because it's on the timer. And because the timer's in the priority order, it's going to call it off in the right time. And when the event happens, it will deal with this. Questions? All right, so what I'm going to do is I ran out of time. I'm going to push this up here, but I want to kind of show you the observer kind of working. So here it is. The guys are moving and boom, it hits. And what it's going to do is when it hits, it's going to change directions. Change directions, play a sound. Change direction, play the sound. Right? And it's all automagically happening, right? All I do is set up and go. And the how we set this up is I set up a collision pair alien versus wall, right? So I take the grid versus the wall grid, right? I do the collisions there. And then I sit there and say add observer, right? So grid observer is, here's my notify. And it says, okay, which wall did I hit, the right or left wall? Change my delta. So my delta direction, right? On my sound observer, play a sound. And that's really it. There's not much more going on. And so, and all I did is I just attached it to this collision. So when these, an alien versus wall happened, I attached these listeners, these observers, and when that collision happened, it did this. So at some point I want to have wall versus grid. So I go in here, see my wall, and I go wall left, and here's my accept, right? Here's my grid. I go, oh, grids happen, collisions happen, I'm done. Go get the active, whatever cull pair is active, I grab it. I set my collision and I go notify listeners, and then boom, goes over here and it goes, okay, subject notify. Boom, now iterate through, call notify, 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 and then it calls all the appropriate notifies. So does that make sense?
Yeah.
And you'll see, and it's, everybody always comments about this class is like, it seems like all we're doing is setup, 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 and then all of a sudden 1, 2, 3, boom, a lot of things start to work. So next week, we're going to go through the sound system. This is really trivial. We're going to make a font system. So the font system is really what we have already. It's the image manager, and we're just going to splat little images and reuse those images. Yeah, so we can have, you know, an arbitrary font. And then the let's see, we'll go through the sound, the font, then observer, then we'll get into input state, a state machine. And then we're kind of done. You know, we start to now just glue this together and make bigger and better pieces. Okay. Questions? No questions? All right, I'm gonna let everybody go. Hang in there. Get this milestone 1 done. Don't stress about it. You probably are more complete than you know. The only thing I'm asking you to be added to it is just you add boxes on the screen. This way we can know that the box manager is working. That's all. So thanks everybody. I'll see you next week. I will get the grading done for those other 2 sprints come in the next 2 days. Thanks.
Thank you so much.
Thanks.
Hey, Professor.
Yeah.
You mentioned at the beginning of the class that some students weren't doing their assignments and you didn't know why.
Yeah.
One of those is actually my girlfriend, and she actually dropped the class at the beginning.
No. No. Yeah, that's fine, but that's not who I'm talking about.
Okay. Well, she just said that you got she got a message saying that you didn't know why she wasn't doing her assignment, and that she needed to do it to pass.
I seriously doubt that. The reason why I'm saying that is I grade off of the active roster.
Okay.
You know what I mean? So as of whatever's in D to L, that's the ones I grade.
Yeah, she actually has the class in D2L, even though it's not like registered for her on Campus Connect.
She's still on it. DL hasn't removed her, so she'll have to contact advising or somebody else to make sure it's off. But DL is coordinated with what the university thinks is active.
I see. Okay.
So that's probably the confusion. Is somehow, there's maybe something wrong with the D2L database, maybe, or some kind of push. Send me a private message with a name, and I can also query administration to see if they know what's going on. But I only grade what's on D2L. So there's a lot of students that were here, and not a lot of students, but there's some students that dropped, and the that they're gone. They're not on there anymore. If the D2L is off, I don't grade it. So that's definitely a thing. So I'll query, but definitely have anybody who's in this category should also contact administration to make sure it is clean, because our D2L at most is 1 day late. So did this other student drop the class within the last day?
No, she dropped it at the very beginning.
Okay, something's wrong.
Okay,
Yeah.
relay that.
Yeah, something's wrong because it's still on my active roster.
Okay, yeah, I'll relay it.
Yeah. Sorry, this is the first time it's ever happened. I've seen times where people add a class and I don't see it for a day or two because it takes a while to propagate. I've seen people delete it and then it takes a day or two to remove, but this has been weeks. So something's definitely wrong with this, and make sure that if dropped it before the drop date, you're not paying for the class also.
Okay, yeah,
So,
I'll relay all that.
yeah. Oh wow, that's weird. Yeah, go contact whoever you deal with registration. I don't know who students deal with that. Is there a registrar's office or something like that you can probably contact?
I'm sure there is.
Yeah, that's probably the best route I would suggest. Until then, I have to kind of go with what's the roster. So
Yep, sounds good.
yeah,
That's what I needed to know.
okay, that makes sense. I mean, that makes sense, but that's why I think we have a discrepancy. The DL says one thing, and the campus connects, from the student's perspective, says a different thing.
Yeah. So all right.
All right, I'm gonna go check it again, just to see. But I printed it out today, and all I do is I print out all the students' names who are actively on there, and I grade down that list. So that's why I know that was active. So
Gotcha.
ooh, yeah, let's get this fixed before bad things happen.
All right.
All right, thank you.
Thank you. Bye-bye.